Hello everyone. So now that we spent a little bit of time kind of practicing breaking down, simplifying these quadratic answers, we're going to continue trying to learn more about how to simplify and solve using the quadratic formula. All right, so I am currently on page 23 of your note packet. So go ahead and turn to page 23 of your note packet, and we're going to continue on here. So for example 2 here, it asks, does this factor? So if you recall, how we factor this is we multiply the first and the last term, which would give us a positive 10. And then for positive 10, our options are negative 1, negative 10, positive 1, positive 10, negative 2, negative 5, positive 2, positive 5. And none of these guys are going to add up to give us a negative 8. None of those answers are going to work. So the answer is no, this does not factor. It's prime. So it tells us we'll use the quadratic formula to solve. So this is showing you, well, sometimes you cannot solve using factoring, which we've already done, but the quadratic formula may work. So let's go ahead. We know that our A is 2. That's our first term. Our B is negative 8. Don't forget the signs. And our C is 5. All right. So remember, it's always negative B plus or minus the square root of b squared minus 4 times a times c all over 2 times, a, which is 2. So then you end up with a positive 8 plus or minus the square root, and I get 64 minus 40. All over 4. So then I simplify that a little bit further. I get 8 plus or minus the square root of 24. All over 4. So then from yesterday, right, we learned how to simplify this root 24, right? So we're going to, I guess today actually you did that. So we take our 24, you break that down, and you're going to do 4 times 6. Take a 2 out in front, you get 2 root 6. So you're going to rewrite that as 8 plus or minus 2 root 6 over 4. Then you look for that GCF on top. You can take a 2 out of 2 and 8. When you take a 2 out of 8, you get 4. And when you take a 2 out of 2, you get 1. So you're just left with the root 6. And then that's all over 4. Then we're going to cancel these out. 2 over 4 goes to 1/2. So you end up with like 1, 4 plus or minus root 6 all over 2, which is the same as just 4 plus or minus root 6 all over 2. So your two answers here are going to be 4 plus root 6 all over 2 and 4 minus root 6 all over 2. And those are your x-intercepts and your solutions, okay? So let's copy, paste that here. These would be your solutions. And if you wanted to write them as x-intercepts, right, you would do 4 plus root 6 all over 2, comma 0, and 4 minus root 6 all over 2, comma 0. Those are the points, all right? So, right, sometimes we're able to get these points by solving, factoring, setting equal to 0 and solve, and sometimes we can't. Sometimes we need to use this quadratic formula, which clearly can get a bit ugly. All right. So now for problem 3 and problem 4, it says complete the square, identify the vertex, and solve to find the value of x. All right. So first, let's complete the square. So if you recall, we do x squared plus 10x, and then we move the minus 1 over. We're going to get rid of the equals 0. Then we're going to go ahead, we do that middle term, divided by 2, and square it. So 10 divided by 2 is 5. When you square that, you get 25. We do not have a leading coefficient, so we added in 25. We subtract out 25. So then we've got x squared. Actually, no, you would write that as x plus 5, right, squared, minus 26. And all that was equal to 0. All right, so now we've completed the square, And it's actually in a form that we can solve. Remember solving these? Remember how I told you guys to get this guy all by himself? Right, you bring the 26 over, take the square root and solve. Let's do it. So we would do plus 26, plus 26. So you get x plus 5 squared equals 26. Ooh, that was ugly. Take the square root. What do we do when we take the square root? You got to do plus or minus, right? So you get x plus 5 equals plus or minus root 26. And then you can bring the 5 over. So your two solutions from solving this way, you would get x equals negative 5 plus root 26 and x equals negative 5 minus root 26. So that's what you would get there. All right, so it says complete the square. Oh, and they did tell us to identify the vertex. I was lazy and I didn't do that. If we look back up here when it's in vertex form, what do we get? Negative 5, negative 26. That is the vertex of this guy. So then it says, then solve to find x. That was this. And then it says, additionally, solve using the quadratic formula. So this, for example 3, we solved by completing the square. Now, we've completed the square before to get it into vertex form. But this was an example of how you can use that vertex form to actually finish solving and get your solutions, right? Now, let's go ahead and try and use quadratic formula. All right. So we've got a... And when you're using quadratic formula, we need it in standard form, so we're going to use this guy up here. We get a equals 1, b equals 10, and c equals negative 1. So now that we've got our a, b, and c, we can go ahead and plug it into the quadratic formula. So we're going to do negative b, so negative 10, plus or minus the square root of b squared, minus 4 times a times c. All right. So we get all over 2 times a, so 2 times 1. So we get negative 10 plus or minus the square root of 100. And then you end up with plus 4, right? Because it's negative 4 times negative 1, which is going to give you a positive 4, all over 2. All right. So then we have to go ahead, simplify this a little bit more. We get negative 10 plus or minus the square root of 104 all over 2. Now what you would do is you're going to have to break down 104, and you will find that you can break down root 104 into 26 and 2. I'm sorry, 26 and 4. So you would have root 26 times 4, which is going to give you 2 root 26. All right, so we're going to do negative 10 plus or minus 2 root 26 all over 2. And then we're going to factor out our greatest common factor from the top, which is going to be a 2. Oops. Which is going to give you negative 5 plus or minus root 26 all over 2. The 2's cancel and you get negative 5 plus or minus root 26. So your answer would be x equals negative 5 plus root 26 and x equals negative 5 minus root 26. All right. Notice how these are the same. You should get the same values. All right. All right, let's go ahead and try this guy. So first they want us, again, to complete the square. Now remember, when you complete the square with a leading coefficient, you need to factor it out of the first 2 terms. So you're going to do 2 times x squared minus 8x, and then we've got a plus 6 on the end. We're going to go ahead and take our middle term, negative 8, divide it by 2 and square it, which is going to give us a positive 16. Now we did not just add in a 16 though, we added in a positive 32. So now we have to subtract out 32. So we end up with 2 times x minus 4 squared. How did I get that? Well, you take your middle term and divide it by 2. And then we're going to do 6 minus 32, which is going to give us a negative 26. All right. So we've got it in vertex form. So we know now that our vertex is going to be 4, negative 26. That is our vertex. Now we need to solve for x. So we set it equal to 0, and we do that thing where we isolate the thing that's being squared. So we're going to add 26 to both sides. So you get 2x minus 4 squared equals 26. Divide by 2. x minus 4 squared equals 13, plus minus, and you get x minus 4 equals plus minus root 13. Add 4, you get x equals 4 plus minus root 13. All right, so just to reiterate, this is how you solve by completing the square. Okay, and of course you could write this as the two separate solutions, right? It would be x equals 4 plus root 13 and x equals 4 minus root 13. Okay, so that is how you would solve by completing the square, which is very similar to what we did on the most recent quiz. So now let's go ahead and solve using the quadratic formula. So here, if we're using the quadratic formula, again, make sure you go back to the standard form. It needs to be in standard form if you are using the quadratic formula. Okay, so we're going to go ahead. We have A is equal to 2. B is equal to negative 16. And C is equal to 6. So we're going to go ahead and plug that into the quadratic formula. We're going to do negative B plus minus the square root of b squared minus 4 times A times C. So we end up with 16 plus minus, and 16 squared gives you 256 minus 4 times 2 times 6, which is going to give us 48. Oh, and I forgot to do all over 2A. Oopsies. Sorry, guys. So it'd be 2 times your A value. So that's going to give us a 4. All right. So now we've got 256 minus 48, which is going to give us root 208. All right. So we'll go ahead and we have to try and simplify this, right? So if we're trying to break down root 208, you should go through, see which perfect squares work, and you will find that 16 times 13 works. So you get 16 times 13, you bring the 4 out, you get 4 root 13. So then you've got 16 plus or minus 4 root 13 all over 4. Now again, we are not done. We need to simplify this, right? So we look for any GCF. We can take a 4 out. So you get 4 plus or minus root 13 all over 4. They cancel and you get 4 plus minus root 13. So your answer here would be 4 plus root 13 and 4 minus root 13. And those would be your two answers. So this shows you, again, how you solve completing the square and by using quadratic formula. These are both good methods. All right. Now let's go ahead. I am going to do one from your homework to try and help you out here. So it says complete the square, identify the vertex, and solve to find the value of x. Additionally, use quadratic formula. So this is literally what we were just doing. I'm just going to do another one to help you guys out. How about I'll do number 2. I feel like this one might be a little bit tricky for completing the square, so I will do it with you. So first thing we need to do is factor out a factor of 3 out of the first two terms here. So we get 3x squared minus 8x, and we got this plus 39 on the end. So we're going to do negative 8 divided by 2 and square it, which is going to give us a 16. Then at that point, we're going to multiply. Remember, when you have that leading coefficient, you need to multiply. So you do 3 times 16, which is going to give you 48. So you added in 48, so you need to subtract out 48. So now we're going to write this inside as a perfect square. You're going to do x, and then you always do your middle term, divided by 2, which gives us a minus 4. Keep the 3 out in front, and 39 minus 48 is going to give us a minus 9. So our vertex is going to be 4, negative 9. And then to solve, we're going to set this equal to 0, right, because it was equal to 0 here. Isolate this guy. So to get that guy by himself, I'm going to add 9. Divide by 3. Get x minus 4 equals 3. You're going to take the square root of both sides, add plus minus. So you get, I'm just going to write it up here because I'm going to run out of, oh, I'm not going to really run out of space. Okay, we're good. You get x minus 4 equals plus minus root 3. You're going to add 4 to both sides. So you get x equals 4 plus minus root 3, which you could write as x equals 4 plus root 3, and x equals 4 minus root 3 as your two solutions. All right, so again, that is how you do that by trying to complete the square. Now let's go ahead and do it by using quadratic formula. So again, when you're using quadratic formula, you need to use the standard form of the equation. So we get a equals 3, b equals negative 24, and c equals 39. So now we're going to go ahead and plug that into the quadratic formula. So we get negative b, so negative 24, plus minus the square root of b squared minus 4 times a times c, all over 2 times a. So you're going to get 2 times 3. So you end up with 24 plus minus the square root, and then you get 24 squared. And then you're going to do minus 4 times 3 times 39, which is 468, all over 6, because that's your 2 times 3. These look really ugly, but we're getting there, we're getting there. So let's go ahead and simplify what's inside the radical. We get 24 plus minus the square root, and then we're going to do 576 minus 468. And I got 108. All right. So, oh, sorry, 108 over 6, my bad. So we're going to go ahead now and break 108 down. So if we've got root 108, you're going to want to figure out what perfect squares go into there. And of course, start with the biggest number that you can. Remember, that's very important. Okay, make sure you start with the biggest number. So you get 36 and 3. So you get root 36 times 3, which is going to give you 6 root 3. So we can rewrite this as 24 plus minus 6 root 3 all over 6. And remember, we're not done. We got to take out our GCF out the top. We get 6, 24 plus minus root 3 divided by 6. So we get x equals 24 plus minus, ooh, hold on. No, I messed up. Hopefully you realize what I did. When you factor a 6 out of 24, you should get 4. So that was my fault. Wasn't thinking there. So when you take the 6 out, it becomes 4 plus minus root 3. Cancel that out. You get 4 plus minus root 3 is your answer. So your solution would be x equals 4 plus root 3. X equals 4 minus root 3. Okay, and those would be your two solutions. And notice how, again, they match, right? You should get the same, if you solve, you should get the same answer. All right, so now let's go ahead. I'm going to do one of the factoring ones, so hopefully you guys remember how to factor here. So they want you to factor and solve. So remember when we learned about the zeros of a function, when we learned about the x-intercept, the solutions, those are all the exact same thing. Okay, so if you recall, how do we find the zeros of a function? Well, you factor it and you set it equal to 0, right? So you got to figure out what multiplies to give us a negative 30 and adds to give us a positive 7. I'm going to use a positive 10 and a negative 3. So you would do x plus 10, x minus 3. And then once it's factored, you're going to set them equal to 0. Don't just change the signs. You guys are going to lose points on that. You got to show that you're setting each of those equal to 0 and solving. So you get x equals negative 10 and x equals 3. Okay, so that is how you would solve using solve by factoring. Now you still need, for number 5, you need to solve by doing the quadratic formula. So I would just do that now so you could be done with it.